So with Farah, what we really wanted to do was to emphasize the whole idea behind the BI hierarchy. And the BI hierarchy is really all about making sure that we use the right tool for the right job. Many of us have experienced reporting tools that the first thing that the mine planner or continuous improvement coordinator does is executes a report and copy and paste that report directly into Excel. So what we wanted to do is avoid that process where we produce reports for people who use reports, just straight up reports, and we provide the analytical capabilities that one would expect from a mining engineer or continuous improvement coordinator. So for that, I'll just start off with just introducing this concept of the BI hierarchy. In this case, at the very highest level, we have things that we might call real-time performance feedback or some sort of status dashboard or status board. And the BI purpose for this is really, how am I doing? And in this case, it's really to provide almost instant feedback to the operator. And this is why on the screen, right in the main screen of Farah, we have, for example, the number of points right there where you're doing all your interaction. On the status board, this is more for like coordinators. And the idea here is, where do I go? What do I do? What should I expect? Think of this as a real-time screen like you might have at an airport. You should be able to very quickly find your flight, where you need to go, what you should expect when you get there. That should be something similar that we have in the operations as well. The next level obviously is dashboard. And the dashboard, it's a little bit less real time, but in this case, it's more, the question that should be answered is, do I need to look into something? And I have this, it's the 20-second rule, but in reality, it's more like a 10-second rule, which is how long you looking at a dashboard should really be as though you're driving your car. If it takes you longer than 10 seconds to read a dashboard, it's not a dashboard, it's a report. So it doesn't tell you whether or not you need to look into something. So in this case, it has to be very, very simple interfaces. Now, these images are from some of our very, very earliest dashboards at North Antelope Rochelle. And what you're seeing here is a dashboard that's constructed 100% out of our live OLAP cubes. So this is actually all in Excel, but it's running in real time, and it's a dashboard that we created, as far back as 10 years ago, of production numbers coming out of North Antelope Rochelle mine from our OLAP cubes. So the next level are more integrated visualizations where you might get more real-time decision making. I'm going to skip over that stuff. But then we get down into shift-to-date reports, sort of like on-demand reports. So in this case, again, we need live data as quickly as possible, but it's shift-to-date. And in this case, the question becomes, do I need to intercede? Also think of it as a halftime coaching sort of document where halfway through the shift, the supervisor looks at it and he has to try to figure out, if he needs to intercede halfway through the shift to make sure things are running properly. Again, this was all from OLAP and data tables. This is SSRS. This is what pure raw SSRS looks like. That's SQL Server reporting services. I believe that Andy might have already reviewed SSRS. And finally, we get down here to the managerial scorecard. These are things that are cultural levers that help the people manage. Now, later on, we'll have a whole focused short course on here. But the question here really is to identify areas that are in need of attention. A managerial scorecard really is to know, what questions do I ask? It's not to answer the question. We get into a lot of problems in BI where we try to produce a report that has answers almost every single question that we could possibly ask. And that's a recipe for disaster because the report becomes more and more complex. Instead, it's better to have a sort of report that drives the questions to ask. And the questions should always be answered by analytical tools. So the analytical tools that we're going to look at is OLAP. Now, this whole BI hierarchy that I reviewed, which should be, an almost half day to full day short course, I'm going to show you very quickly within Farah all these different levels of the data. Now, what you're looking here, this is SQL Server. Many of you are already familiar with it. On the left side over here, just like any other Windows application, you have sort of like a folder structure. This folder structure is more related to what is on the server. This MISOM-dev MS 2012, this is the database that hosts our dev box. When I open this, you will see a whole bunch of databases, but the only database that's actually live data is going in is this MISOM Farah over here. Everything else is sort of like backups and other stuff. But if we open up MISOM Farah, so this is standard SQL Server, is 2012. Obviously, we'd prefer 2016, but anyhow, these tables, there's a lot of tables here. You might be intimidated by it. Don't be intimidated by it, because the only one of all these tables where there's data going into it, most of them are backups. Looks like we have a lot of backups here, but most of them are backups and other stuff. In reality, the only tables that actually are receiving data are one, LFMS events, LFMS points, and LFMS point details. Everything with an underscore afterwards that you see right over here, these are all just backups and other stuff that we probably need to clean up. But LFMS event point details, LFMS events, and LFMS points, this is the live location where the data lands. So this is all live data. So it looks like someone, I don't know who, this equipment DD95 is the name, or no, let's see what the name of the site is here. So default, okay, so someone has logged in and is creating records, as you can see, as recently, as whatever minutes ago. Okay, so that's Dan. And we can tell it's Dan for a couple of reasons, but one, because he just said it, but two, also his tablet is producing time from where he is. So you can see his time, even though we're in Tucson, and the server, you can see the server time is 11:02. You can see that Dan's time produced by the tablet is at noon, Salt Lake City time. So you can see his data coming in here. So he's logging a lot of mile per hour. We send up a regular diagnostic point that has records in it, et cetera, et cetera. So, okay, so a time. So let's talk about the time perspectives that we have here. Okay, so a truck haul cycle has a beginning and an end. In our nomenclature, we call this an event. Okay, anything with the start time and an end time is an event. Now we're capturing cycles. So these are cyclical processes that mining typically has quite a few of. So for example, a truck cycle. So imagine this as being a haul truck cycle. We call these cycles, has a beginning and an end. Now, this is, in a lot of reporting in mining, this is enough for your day reports or your shift reports. However, as a continuous improvement person, or for dispatch or for mine planning purposes, we also need to know the sequences within a cycle. So the sequences can be, for example, for a haul cycle, can be queuing, spotting, loading, hauling, queuing, maneuvering at the dump, dumping, and then haul empty. Now, some mines might want far fewer sequences in the cycle, but regardless, all of these as well have a start time and an end time. Okay, so these intervals, what we would also call them events. Now, each one of these events has a point in time. For example, a point could be arrive at shovel. A point can be you begin your spot. So arrive at shovel and begin spot are what bounds the events. So as you can see, arrive at shovel, begin spot. We're logging both the points in the points table and the events in the event table. So it's sort of like doubling up, I guess, in a sense, the time functions. but it's very important to keep these points conceptually separate from the event ones. Okay, so points indicate a point in time. So that's why when you look at the actual data, we have our point GUID. So a GUID is essentially, in database terms, it's a key. It's a way of uniquely identifying something. A GUID is an acronym for a globally unique identifier. So this is a number, as you can see, that's randomized in a way that they'll never ever actually be able to be repeated. So this is a common thing in databases where you have these GUID things as keys. It's better than, for example, incrementing things upwards, because then people could perhaps interpret as the increments being where you want to inject something in between, but the increments would be off. So it's far better to use these GUID things, as you can see. So as you can see in the point table, the GUIDs will never ever repeat. Now you can see this site GUID over here. This is related back to link to a table, the site table. As you can see, this is a unique identifier within the site table. So the site table org. Let me see. org.sites. Oh, I see why. I'm not in Farah. I'm in master. Let me switch over to Farah here. Okay, so here you can see that what 6.9 is our default site, as you can see. So let me get back into this points here. Okay, so all these GUIDs refer back to something else. Now, in order to speed up the BI, we've also included columns that are the key columns related to, or the important columns related back to these GUIDs, okay? But there's a lot more details in each one of these that relate back to it. So anyways, so as you can see, equipment GUID, and the equipment name is also over here. Now these tables are not normalized. If they were normalized, you wouldn't see this 214 here, because the 214 is related exactly to this equipment GUID. But in order to speed up the BI, we also include equipment name. So as you can see, we have all these different columns, but the key thing I wanted to point out here is the point. This timestamp is our point in time, where this particular record that Dan's tablet is creating is writing up to the database. Tablet UUID is a unique identifier for the particular install of that particular app. So if he reinstalled it on the same tablet, this would be a different number. But this way we can keep track of the installs. But getting back to what a point or an event is, we can see these things with the start time and end time, and these are all points. Now, we might also want to log other points. So for example, you saw that we have a lot of points that are mile per hour. This is also a configuration where we can capture a heartbeat of the mile per hour every X number of minutes. So as you can see, we're keeping track in the database, Dan's speed every 20 seconds. Or is that 120 seconds? No, it looks like it's every 20 seconds. So every 20 seconds, we take a heartbeat snapshot of Dan's speed. As you can see, he's not really moving anywhere here. Now, we might also want to capture other information that are these point type data. So for example, let's say machine data. One day when we link the machine data sensors, again, we might want to take a snapshot or a time, whenever these particular things happen, we want to take a point in time for that data. So we have a lot of different types of points, but keep in mind that a point is a point in time, whereas an event is anything that has a start time and an end time. So for example, a key additional type of event that we have is the time status. We call that status change. So this is anytime we have a start and an end within that particular parallel time. Now, some people were asking, oh, well, my time continues on in my haulage cycle, let's say, for example, even when I have a delay. Yes, that's the way the time works. If you want to know the total ready time within a full haul cycle, we can calculate that separately. But right now, we're tracking on parallel timelines the statuses, the sequences, and the cycles. Okay, so I'm going to escape from here and just go back to the database. So that's the points table. This is the events table. So as you can see, as you can see, I guess Dan has a beacon on his refrigerator. Is that possible? Oh, okay. Okay. Well, as you can see, there's some events that have an open and a close. What you're seeing here, 1969, 1231, 0 in 0 or sometimes null in SQL. This is the time that SQL believes the Earth, sort of like the universe, started here. So it's so just ignore when you see this time like this, where it's less than the begin time. Just know that this event has not closed yet. Okay. We also regularly update the status change events so we can calculate things in real time. So even if this isn't closed, only for the status events time are we updating and saving regular records here. But otherwise, you can see wherever you're not closed, we have this null value. In other words, this time hasn't closed. However, if someone went and turned off that beacon, within a few minutes or in a few seconds, we will see that all these events have closed. All right, but right now they're still open. But these other ones have an opening and a closing and a duration. Okay. So that's the events table. Now, and finally, we also have additional details and additional details. So additional details, we can see some other things. Okay, so these, I recognize this stuff. These are the diagnostic points that that Dan's tablet is writing. So it's anyhow, these are the diagnostic points being written out. These are the beacon snapshots. So we are certain distances from different beacons, etc. I'm not going to get into all the different points because that's probably best for a more intense training. Just know that the 3 key tables that are being written to on a regular basis live are LFMS points, LFMS events, and LFMS point details. Now, the other table being written to, but not like continuously, it's only being written to when you actually save or submit a form, is the form data. So here is the form data. Now, you can see here this document is a unique document. It's this site. I'm not sure who. Oh no, okay, that's Ghana. But so this site, this form good. I'm not familiar with that form good. You guys must have just created a new type of form. So this user logged in. Okay, so it looks like Aaron saved something on Friday, synced it, and this is the data right over here that makes up that form. It is saved in a type of data structure called base 64. So let me show you what that looks like. So base 64 is essentially an encoding of all of the data in the form. Okay, so the first thing that we would need to do then is we would need to take it from base 64 and make it into readable text. We have a whole bunch of tools that does that for each and every single one of these document structures that are saved. Okay, so just know that it gets first transmitted into base 64, and then from there it goes into JSON, and then we parse that data from JSON into a readable database format. Now, so the tables that we reviewed so far: LFMS event point details, LFMS events, and LFMS points. Those are the three being written to continuously, and the only other data, the only other table being written to by the app is this forms.form data. Now, the other key tables to be aware of: geo.region and geo.region coordinates are live tables that are actually written to by the app when you're creating polygons. And the other table that's very, very important is this LFMS schedule patterns, but I overheard that they didn't give training on how to create a pattern. But essentially what this table does is it lays out the structure of your shifts so that every single minute in the day is accounted for as within a shift or shift date. Because in production, we never go from midnight to midnight when we're talking about a production report. All production reports typically do it on a shift date basis, and the shift date is the date on which the shift started. So for example, if you have two 12-hour shifts, each starting at 7 a.m. and 7 p.m., even though the 7 p.m. shift ends the next day at 6:59 a.m. the next day, it's still considered the same shift date. Okay, so those are the core tables that the app writes to. Now, the app is continuously looking at those tables. For example, the points table. Let's go to the points table, LFMS points, and let's remove this top 1,000. So just for the SQL novices out there, so all that this query is saying is say select, as in bring back, star means every single column from this table, and you want to order it by the timestamp in descending order. So when I click execute on here, it will bring back a huge amount of data. As you can see, there's 54,000 rows in this particular table. Now, what the app right now is continuously doing is it's writing to a node JS on the server, and it's looking at what data currently exists in the server, and if those points don't already exist in the server, it writes those points. But you can imagine every time an app connects to the server and wants to know a list of points that exist or don't exist, it has to go through these 54,000 or more records. And so what you want to do is you don't want it to get into the millions and millions of records which actually exist in the full database. You just want to have a snapshot so that it goes into it on a regular basis. So what we do is we actually take those points, leave a few days worth of points, and that's configurable, but leave a few days worth of points in the live table, and the rest of the time go into this hist table. So all of the reports are actually executed against this points hist table. So you will see that there are a colossal amount of points in the points hist table. So you can see the query executing here. It's executing, and when it's done, it'll give me a number. So, but essentially, all it is doing is bringing back every single point in the database here. Okay. Well, while that continues to run, there's probably like maybe a few million rows in there. Um, that very first and most important process is all done through what we call stored procedures. Stored procedures are little bits of code that does things on a regular basis. So as many of you have been involved perhaps a little bit in software writing, when you write code, you don't write it all at the same time. You create little utilities, little bits of code that does a particular function. Now, as you can see, we have a lot of stored procedures here. They all do different things. So for example, these DZ things populate the DataZen stuff. These import data that it helps us import data into dev. Investigate, these are just like sort of training tools that help people understand how these different things work. So as you can see, there's a lot of different functions over here. The way what I like to do is I like to create a nomenclature for this stuff. So for example, anything that has investigate underscore only does training, only helps you understand how these different points work. KPI and DZ, those are for the DataZen functions. Real-time underscore BI, those populate the web visualizations. Return brings back data that's then used for other stuff. Update are things that are run in order to make sure that the backups are updated, so on and so forth. So when we deploy to a site locally, all we need to do is copy all of these different things into the local database using some sort of backup method. So that's a lot of data that we're bringing back. So instead of executing this full query, oh no, here we go. So as we can see, there are 4.5 million points in the database right now. And that's a boatload of points. It's quite a bit of points. And so and it took 2 minutes 44 seconds for all of that data to come back. So it's a lot of data. And it's probably, executing queries against these tables is not good for doing analysis because we don't want to wait 2 minutes every time we want to analyze our points data. So what we want to do is we want to create tools that will help us very quickly analyze and slice and dice through the data. Now, what we're doing is we use stored procedures to create an OLAP environment. OLAP stands for Online Analytical Processing. And what that does is it goes and populates all of these BI fact events table and all of these dim underscore tables. Facts in database speaks are very simple, straightforward things like events and so forth that have foreign keys. In other words, that link back to these more detail-oriented dimension tables. Now, I teach a whole OLAP short course. Some of you have taken it. I'm not going to get into it now. Just know that these stored procedures, so for example, update dim, so update the dimensions, and update fact tables, for example, just go and update all those fact tables. Takes it from points hist into the fact tables.